everyone, and I'm so glad that you could join us for today's lesson. Today we're going to be looking at factorizing polynomials. Now, you've done a lot of factorizing up until grade 12. You'll remember you've done things like difference of two squares, you've done factorizing trinomials, completing the square, and all these other things that I can't even remember right now. You've done plenty of them, right? So you've learned so many different ways to factorize, and yes, there are more ways, okay? So today we're going to be looking at factorizing. Specifically, as we get into the lesson, we will look at factorizing cubic polynomials, all right? But we're first going to start off by looking at things like identifying polynomials. We're going to, as I said, factorize cubic polynomials, and we're going to look as well at the factor and remainder theorem. So really just giving you more ways to add, or more ammunition really to your factorizing repertoire, so you can learn all these different exciting ways to factorize, okay? All right, so with our key concepts for today, I really want you to start by thinking about what is a polynomial. And the way I'm going to phrase it now, and the way you'll see your question is phrased, is to already make you sort of start thinking, well, what is a polynomial? Do I really know what it means? And that's what I want you to get from this key concept section is, what is a polynomial? We will obviously discuss it in more formal terms, but I want you to think about the word poly and nomial, and then think about how it relates to the questions that I'm going to ask you in this key concepts section. And when you think of the word poly means many. Nomial, for our case, means terms. So when you're thinking of polynomial, we're talking about many terms, okay? But then we can get different types of polynomials, and that's what I'd like you to have a look at now. I'm going to give you a little bit of time to answer this one, so you can have a look at the questions on your screen, state whether the statements are true or false, and you've got a couple of expressions there. We will discuss this together just after these 2 minutes that I'm going to give you to look at this. Right, everyone, so we're starting our discussion on factorizing polynomials by identifying what is a polynomial. So I've already mentioned to you that polynomial, poly means many, and nomial, we can think of it as terms, so many terms. That's what we're talking about, but there's obviously a more formal definition. So I want to go into that definition before we answer these statements and see which one is true or false. So you will see that a polynomial is an expression that involves one or more variables having different powers and coefficients. Now remember, your coefficient is your number in front of your variable. Your power, obviously, is your exponent. Okay, so if you have a look at an, xn, so what an represents is a coefficient, and that's the coefficient of your variable x with power n. Okay, so a polynomial is an expression that involves one or more variables having different powers and coefficients. And we say one or more variables because obviously instead of just having x, you could have x, y, and so on. Okay, the important thing for you to note here is that your exponents, the exponents of your variables are whole numbers. That's very important, and that helps you to identify whether you're dealing with a polynomial or not. Okay, so your exponents of your variables are always whole numbers. All right? Now, the special types of polynomials you get, well, a monomial, a polynomial with just one term. So, for example, even a constant could be a monomial, so something like 6, or even something like 6x. All right, that's a polynomial with one term. A binomial is a polynomial that has two terms. So, for example, x plus y, two terms, and a trinomial is a polynomial that has three terms. So you can imagine we can give you a different example there, but instead of giving you more examples, I want you to just have a look at your statements again, and let's discuss this. Okay, so the first one, you're told that the expression 3y squared plus 2y minus 4 is a trinomial of degree 2. Let's talk about this a little bit. Degree 2, remember the degree 2 tells you the order of your polynomial, or in other words, the highest power. It tells you what the highest power is of a polynomial where you're dealing with just one variable. Okay, we call it univariate. Okay, so we've just got one variable and the degree is the highest power of that variable. So the expression is a trinomial of degree 2. Yes, that's true. It's a trinomial. It's got three terms. All the powers are whole numbers and the highest power of the y is 2. So that one's true. Number 2, you've got 25 z to the power of 5 minus 36 times the root of z. Square root of z is the same as saying z to the power of a half. Is that a binomial of order 5? Interesting. So some of you will say, okay, well, there's two terms there. Yes, it's a binomial, but you've got to be careful because we made a special a sort of a property or a special rule here where we say that your exponent has to be an element of whole numbers. So we've made a special condition on the power of your polynomial. And if you look at z to the power of a half is not a whole number. So therefore this is not a polynomial, and it's definitely not a binomial of order 5 because your power of z is fractional. It's not a whole number. 25 is a constant polynomial of degree 0. That is true because 25, and I'm saying true but I'm writing false. That is true. 25 is a constant. Yes, if there's no variable attached of degree 0, well, we could write 25 as 25x to the power of 0. So that's fine. A cubic polynomial has three terms and all the exponents are natural numbers. So here you've got to be careful because they're saying a cubic polynomial has three terms. Now, it can have three terms, but it can have more. The thing about a cubic polynomial is what it's really describing is what the degree of the polynomial is. So a cubic polynomial is telling you that your degree of your polynomial is 3. So the highest power is 3. All right, so this one is going to be false, because it may have three terms, but it could have more. Okay. And yeah, so we've just gone over what the definition is. We see that the last statement there, a cubic polynomial has three terms and all the exponents are natural numbers, is not true because a cubic polynomial can have more than three terms. Okay, now that idea of a cubic polynomial is really what today's lesson is built on, because we're looking at factorizing cubic polynomials. So it's important for you to understand what the definition of a cubic polynomial is. And also what's really nice about dealing with polynomials, and the reason that we make this such a hard and fast sort of rigorous rule, is because polynomials are easy to work with because they work in a way that we understand, and if you graph them, they make smooth, continuous curves, and you can add them together and you'll get another polynomial. If you multiply them together, you'll get another polynomial. So it abides by rules and laws that we have a whole body of education in maths that covers. So we like polynomials. That's why there's such a rigorous definition about what a polynomial is. It makes it easy to work with. Okay. So we were talking about factorizing in the beginning of the lesson, and I said to you, you'll remember that you did things like taking out a highest common factor, you've done difference of two squares, difference of two cubes, sum and difference of cubes. You've also looked at factorizing trinomials in previous grades, and today we're going to be looking at factorizing cubic polynomials, all right? But before we get there, we need to know certain other concepts. And this is what I would like you to do now, is to look at a different concept. And many of you are familiar with the concept of division, but we're going to make a sort of like a rule that we can use when we're dealing with division of polynomials. So I want you to get to that concept of polynomial division by looking at division of just integers, which you already understand. So I'm going to give you a minute to have a look at what's on your screen, and then we will go over this together and see how it relates to division of polynomials. All right, guys, so what this would show you is that division of polynomials, which we're going to talk about now, really just relates to division of integers, and we've just extended this concept to division of polynomials. All right, so here you were told that 6 students are at a product promotion and there are 15 free gifts to be given away. Each student must receive the same number of gifts. Determine how many gifts each student will get. Well, this is a very simple problem for most of you. You know that, okay, there are six students and there are 15 gifts. So if I were to say 15 divided by 6, my answer will be 2 times 6, or 6 times 2 gives me 12, plus my remainder of 3. Okay, so that's pretty simple for you. How many gifts will each student get? Well, it looks like each of them are going to be getting 2 gifts, and there's still going to be 3 left over. Okay, so that answers the next question, which says, how many gifts will be left over? Well, they're going to be, if we break this up, we say, well, 15, which we call the dividend. So if I do a division symbol on the side here, we've got 15 is our dividend, is what goes inside. 6 is your divisor, that's what you're dividing by. Your answer is 2, that we call the quotient. Your quotient is your answer to division, and then your remainder here is 3. All right, so we've just broken it up and explained to you what each of these terms refers to. So how many gifts will be left over? There will be 3 gifts left over, and each of them will get 2. Then I said to you, use the following variables to express the above situation in a mathematical equation. So we see that A is the total number of gifts, B is your total number of students, Q is the number of gifts for each student, and R is the gifts left over. So therefore I can say A, which is the total number of gifts, is equal to the total number of students, which is B, times the number of gifts for each student, which is Q, plus your remainder, which is 3. And if you relate this back to 15, is equal to 6 times 2 plus 3, hopefully you can directly see that correlation. All right. Now this is the important thing. This rule that we already know for division can be extended to include the division of polynomials. So if you've got a polynomial a of x and it's divided by a polynomial b of x, then the answer will be q of x with the remainder of rx. So therefore, setting it up as an equation, we have our polynomial a of x is equal to our divisor times our quotient plus the remainder. And you'll note that your divisor is not 0 because you cannot divide by 0. All right. Also, a cubic polynomial is an expression where the highest power is 3. So we say the degree of the polynomial is 3. And the general form of your cubic polynomial is y is equal to ax cubed. Y is equal to ax cubed plus bx squared plus cx plus d. Okay, so that's what we're going to be looking at factorizing as we go into today's lesson. So I think now's a good time for us to take a break so that you can really just go back and really remember what a polynomial is, remember how you can relate your division of polynomials to basic division, and hopefully that makes the rest of today's lesson very, very simple for you. We'll be back after this. Welcome back, everyone. So a reminder, in today's lesson we're looking at factorizing polynomials, and specifically we're looking at factorizing cubic polynomials, which is important for later work that you are going to be doing in grade 12. All right, so we're going to kick off this session by looking at the first question for today. So I'd like you to have a look at this question 1, where I've asked you to find the remainder Rx if your polynomial ax is divided by bx, and then I've given you a method or a formula that you need to use to write your answer in. So that's the form that I would like your answer in, and you can use whatever method for division you know. Okay, I'm going to give you 2 minutes to have a look at this. Okay, everyone, so here I asked you to find the remainder, and I said you can use whatever method you know, and I gave you the general form in which you should write your answer in, which is your polynomial a of x is equal to b of x times q of x plus your remainder. Okay, so many of you already know how to use long division in order to work out your remainder. What I want to show you today is called synthetic division. Now, synthetic division is really a simpler, more efficient way to factorize, well, not to factorize, to find the remainder of a cubic polynomial or even a fourth degree polynomial or higher, all right, without actually having to write down the variables and the powers of the variables, okay? So we're going to go through that method of synthetic division together, spend quite a bit of time giving you an idea of how you can use it, take down the steps if you already don't know how to use synthetic division, but this is an alternate and many feel a simpler version of long division, okay? So the first thing we're going to do in synthetic division is make sure that your dividend, okay, so that's your function a of x in this case, make sure that your dividend is in descending powers of x. So you've got 2x cubed minus x squared minus 6x plus 16. It is all in descending powers of x, all right? If there was a term of x missing, so say there was no x squared term, say that wasn't there, then what you would put in is a 0x squared. Okay, so you must always include that variable with its power, even if it's not there. Okay, but here we've got each of those variables with their powers and we've got their coefficients, so we make sure it's in descending powers. The next thing you're going to do is write down the known and the unknown expressions. So we know that we're taking 2x cubed minus x squared minus 6x plus 16. We know that's going to be divided by x minus 1. We're going to get an answer to that, which is our quotient, and we're going to get a remainder. And now what we're going to do, and this is what I'm going to go through with you in a lot of detail, is we're going to use synthetic division to determine the quotient and the remainder. All right? There is steps that have been written on your screen for you, which you can take down and you can follow, but these steps are basically what we are going to do as we go through this question. Okay, so you can simply take down what I'm doing with you, and this will be all of these under step 3. This is what we're going to be doing. All right, that's what we're going to be using to determine our remainder. So the first thing we're going to do is we are going to use synthetic division by writing down the coefficients, so just the coefficients. So I set up what's similar to a division line that you're all used to. So I'm going to use just the coefficients of my a of x, my dividend. So just the 2, the minus 1, the minus 6, and the 16. I'm going to write that underneath the horizontal bar. Okay, so we've got 2 minus 1, so these are just the coefficients, minus 6 plus 16. All right. Then your divisor is always going to be, so remember your divisor here was, you were dividing by x minus 1. So the number that you put in your divisor is always going to be the one with an opposite sign, and it's going to be your number 1. Okay, so here our divisor is just going to be 1. So if you think of it in this case as if I'm dividing by x minus 1, if x minus 1 were equal to 0, then x is equal to 1. That's the value that you're going to use as your divisor. I'll show you that this always works. So even if you're working with divisors that are not where your coefficient is not 1 here, so say you had 2x plus 1, then your divisor, you make the coefficient of x 1 by saying if it was equal to 0, x would be equal to minus a half, and that's what you'll divide by. Okay, so you always change the sign, and it's always your constant divided by the coefficient of your linear variable. All right, so I've put my divisor there as 1, okay, and what we're going to do is we're going to work out what the quotient is, and we're going to put those answers on top of the line, right? So how do we do that? Let's go through that step by step, because all I really need is the coefficients. Remember that when you're doing this, right, the quotient will always be 1 degree lower than your dividend. So we're always going to have, because this is now cubic, my quotient will then be quadratic. It's going to be 1 degree smaller, 1 degree less, sorry. So your quotient will be quadratic if your dividend is cubic. Okay. All right, so let's go through it. So my first quotient, I want to find out what is Q2 up there. So Q2 is always going to be the same as the coefficient of your x cubed term. So it's going to be equal to A3. So in other words, my Q2 is going to be the coefficient of the x cubed term in this case. So it's going to be just 2. So that's what we put up there. We then need to find out what Q1 is, which is the next quotient. So Q1, we're going to take the coefficient of the x squared term, which is minus 1. And we then, instead of subtracting like we would do a normal division, here we add everything together. So we're going to say minus 1 plus the quotient which we just worked out, which was 2, times my divisor, which is 1. And that gives me an answer of 2 minus 1 is just 1. And that's what I'm going to put up as Q1. All right? Then we need to work out Q0, which is the coefficient, all right, of your constant term. So to work out Q0, it's going to be minus 6, which is your coefficient of your x term, plus the answer you just worked out, which was Q1, which is 1 times 1, and that's going to give me a minus 5. So minus 5 is now going to be this value that we put up here, our Q0. All right. We then get to the part where we need to work out the remainder. So what is our remainder? So we go through the same process. Your remainder is going to be your 16, which is your constant term, plus your Q0, which you've just worked out, which is minus 5, times your divisor, which is 1, and 16 minus 5 gives me 11, so therefore my remainder is 11. So your remainder is 11. So this 2, 1, minus 5, what are those? Remember, those are the coefficients of your quotient. So therefore I can now set this up like this. So I'm going to have, well, 2x cubed minus x squared minus 6x plus 16 is equal to x minus 1 times my quotient. Now remember, you've already got your values were 2, so it's 2x squared. And then you got your other quotient for your x term was 1, so it's going to be plus x. And then we got the constant term was minus 5, and plus my remainder, which is 11. These values, 2 plus 1 minus 5, was what I was working out. So those were the coefficients of my quotient. All right. Now, guys, this is, for some of you, maybe a new method. So you might be feeling a little bit resistant. I can promise you, with a little bit of practice, it just becomes so quick and so much easier to do than long division. So I want to put down the steps for you to work out how you can work out the quotient and the coefficients of those quotients for any long division, okay? And it doesn't matter, as long as you're dealing with a linear divisor, it doesn't matter what the coefficient of the x is, it can work for anything, all right? So I want to put down the steps. If you didn't really quite get what we were going through there, take down these steps, and hopefully when you go over it again, when you're looking at it in your quiet time and you're studying, you will understand what we're doing here. And hopefully most of you already get this. Okay, so let's put this down, our steps. All right, so we have, remember that your quotient will always be 1 degree lower than your dividend. So the general method, so say your a of x, that's your polynomial, your dividend, is a3, that's your coefficient, remember, it's not a function, that's a coefficient, so it's a3 x cubed plus a2 x squared plus a1 x1 plus just your constant term, so your a0, all right? And your divisor is cx minus d. All right, so this is just the general method we are going through. Your quotient will take the form some coefficient times x squared. Remember, it's always 1 degree less than your dividend, plus some quotient times x plus your constant term. And your remainder is obviously r of x. All right, so our general form is going to look like this, and I'm just going to write it down for those who are making notes of this and would like to use this as an alternate method. So this is what we're doing. You're going to have, under your horizontal sign, you're going to have your horizontal bar, the coefficients of your cubic polynomial, so a3, a2, a1, and a0. And then your divisor is always d over c. I showed you how to get that. You're basically taking your divisor, cx minus d, you're making it equal to 0 and solving for x, and that's really what you're going to put as your divisor. And then q2, that's your quotient, and these are the coefficients of your quotients. All right? So we determined by the quotients. I'm not going to do them for all, but q2 will be equal to a3, the coefficient, a3, plus q3 times d over c. Now, when you're dealing with a cubic polynomial, your q3 is always 0, okay? So therefore, your q2 will always be a3 when you're dealing with a cubic polynomial. Then q1, which is the next coefficient, will be a2, coefficient there, plus q2 times d over c, and then q0 will be equal to a1 plus q1 times d over c. Okay, and then you get your remainder following the same process. Okay, so this is really just the steps, and I've really spent more time probably than I should have looking at this, but just because it is a more efficient way, if you can get this right, it is a more efficient way to later on factorize cubic polynomials as well. Okay, I think it's time for us to take a quick break so that you can think about all of this, remember all of this. When we come back after the break, we're going to be looking at remainder and factor theorem. Welcome back, everyone. So we have looked at, just before the break, we looked at synthetic division, and you saw that it could be a better way for you to do long division, because sometimes you do need to use long division, especially when you're factorizing. However, you don't need to always find your remainder by doing synthetic division or long division, because that's going to take you a long time. So therefore, there's this theorem that's developed called the remainder theorem, which makes it much easier for us to find the remainder when we are dividing two polynomials. So that's what we're going to talk about now. We're going to look at finding the remainder using the remainder theorem when you've been given two polynomials, g of x and h of x, and I'm going to go through this with you. So you've got your two polynomials given, and we're going to use the remainder theorem rather than the long division or synthetic division, okay? The remainder theorem says that if you've got a polynomial p of x, which is divided by cx minus d, then to find your remainder, you will find p of that divisor d over c, all right? And I showed you how you get that value d over c when we were looking at synthetic division, but just a reminder, if cx minus d is equal to 0, then x will be equal to d over c. And that's how you know what value to use and what value to put in place for your polynomial when you're trying to find out your remainder. So using that concept, we are asked to find the remainder using the remainder theorem of g of x, 3x to the power of 5 minus 8x to the 4 plus x squared plus 2, and h of x is 2 minus x. So therefore my divisor, so putting it back to my theorem, my divisor h of x, if 2 minus x is equal to 0, then what am I going to be dividing by? I'm going to be dividing by 2, all right? So therefore, or what am I going to be using? Let me rephrase that. What am I going to be using to be able to find my function value? I'm going to be using the value 2. So therefore, to find my remainder, I'm going to say g of 2, all right, which is d over c, okay, is going to be equal to function value. What is my remainder? Substitute your 2 in place of x, Okay, and we do that. You can then use your calculator to see what your answer is. I've already used my calculator and I've got the answer here is minus 26. So therefore what we're saying is when this function, this polynomial, g of x is divided by h of x, we will get a remainder of minus 26. Okay, so the remainder, very easy for us to find out using the remainder theorem and using this quick function value way so that we can see what the value of g of x is when x has a value of 2. Okay, so that's really the remainder theorem in a nutshell and really simplifying it down to a point where it's the most basic way to understand it. Okay, you're simply finding the function value when you're dividing by a certain function. All right. This is an important concept as we take it into factor theorem now, because what happens in factor theorem, and you know, for example, like an integer 6 divided by 2. 2 is a factor of 6 because when you divide 6 by 2, it leaves no remainder. Okay, so this concept is linked, the factor theorem and remainder theorem are linked together. And what it really tells us is that when we find the function value and our answer is 0, right, then the function we're dividing by is actually a factor of our dividend or our polynomial. Okay, right? So I want you to think about the factor theorem. Think about it a little bit as you look at this question 3. I'm going to give you some time just to take it down and we'll discuss it in more detail. So I'll give you 2 minutes to take this down. Okay, everyone, so let's talk about this factor theorem a little bit more formally now. So what I said to you as well is that if you're taking an integer a and you're dividing it by an integer b, and b divides perfectly into a with no remainder, then we know that b is a factor of a. Now, similarly, you can extend that idea to polynomials. So if you have a polynomial a of x and you're dividing by a polynomial b of x, and if you get an answer q of x with no remainder, then b of x is a factor of a of x. All right, so that's really what the factor theorem says. Let's apply that to this question. So we're using the factor theorem to determine all the factors of the following expression. Okay, so this is what we've said so far. So if we have a polynomial, so if a of x, right, is divided by another polynomial, b of x, and your answer, your quotient, and your answer is q of x with no remainder. So with your remainder Rx equal to 0, in other words, then we know, then we can say that b of x is a factor of a of x. All right. Now, in general, before we go through the question and get the answer there and factorize that, in general, to factorize a cubic polynomial, these are the steps that you follow. So factorizing a cubic polynomial, and I'm just going to abbreviate that. This is what we do. The first thing we do is we find a factor, we look for a factor by trial and error. Find a factor by trial and error. And many of you would have already been doing this section at school, and you sometimes think, oh, well, this is so frustrating. Is there no quicker way? Unfortunately not. You have to find your factor by trial and error. So you consider, okay, now what I actually just want to mention to you before we carry on. Right, so if we find a factor by trial and error, consider what we were doing here, our x cubed plus x squared minus 17x plus 15. A nifty trick that I give a lot of learners, and well, certainly everyone that I teach to use, is that you will only try numbers that are factors of your constant term. So I will only try numbers in my trial and error method that will divide into 15. So I'll try 1, I'll try 3, I'll try 5, I will not try 2. 2 is not going to work. I will not try 6. 6 is not going to work, okay? So only try factors of your constant term when you're doing your trial and error method. This limits the number of numbers you've got to try. So that's a nice hint for those of you who are struggling to factorize and find your factor, is you only consider numbers that divide into your constant. Okay. In your original dividend. All right. And we'll go through all of these steps as we do this together. You then use your factor theorem. Use your factor theorem to confirm or to check that C over D is in fact a root. Remember, a root being an x value or a solution to your equation. And we show, this should be D over C. We show that P of D over C is equal to 0. So all of this is just theory. When we do the actual working out, it will make more sense. Okay, and then you apply your standard methods, apply your methods for factorization at the end, whatever methods you have learned so far. Now, one of the ways that you guys have learned to factorize is by doing long division, and I have shown you synthetic division now, which you can also use to factorize. What I'm going to go through is division by inspection as well. Okay, so I'm going to factorize this cubic using division by inspection. So this is an alternate method for those of you who like to do maths in a very efficient, quick way. This is an alternate for you. All right. So we note here that they asked us to factorize, and we've got f of x was equal to x cubed. Let's just write that down again. So f of x was equal to x cubed plus x squared minus 17x plus 15. Now, the first thing I need to do is to check for a factor. So trial and error, I'm going to try different values of x that divide into 15. So for example, by trial and error, if I try the value of 1 for x, so wherever there's an x, I substitute a 1, and I'm going to see what my remainder is. if your remainder is 0, then x minus 1 is a factor of f of x. All right, so I substitute 1 in. 1 plus 1 is 2. 2 minus 17 is negative 15. Negative 15 plus 15 is 0, and that's fantastic. So on the first go, we can see that 1 as a value for x gave us a remainder of 0. Therefore, we can say that x minus 1 is a factor of f of x. Okay, so you see how that relation works. If your remainder is 0, you've actually found a root of this polynomial f of x. So we know that x minus 1 is a factor, but I need to find the other factors. So this is where I say to you, you can actually at this point use that method for synthetic division, which I showed you, where you just then work out the coefficients of your quotient and then factorize that quadratic further. So please try and factorize using that method, or you can try the method I'm showing you now, which is division by inspection, or if you still prefer to do your long division, you can do it that way. There's no sort of hard and fast rule to say to you, you've got to do it in this way. No, there's different methods. If you use the methods correctly, they will get you to the same answer. So I'm not forcing you to use any one of the methods. All right, so we've got our factor. Let's do our division. So division by inspection works like this. I'm going to set this up as x cubed plus x squared minus 17x plus 15 is going to be equal to my divisor x minus 1 times some quotient q of x. Now remember, you know that this q of x has always got to be 1 degree lower than your dividend. So if you were dividing an x cubed function by an linear function, you're going to get a quadratic quotient or a quadratic answer. So therefore, this is going to be x minus 1 times some quadratic function. Now we need to work out what this quadratic function is, and this is where we're doing division by inspection. Okay, so it's really just by looking at it and getting our answer. We know it's quadratic, so it's going to be some ax squared plus bx plus c. The coefficient of the first term here, we take, simply all you do is you take your cubic function, you divide by the x, your divisor, all right? So you divide x cubed by x, that gives you your first term in your bracket, which is x squared. How did I get that? I simply took x cubed and I divided it by x. Then to get the constant term in your bracket, you're simply going to take your constant term, which is 15, divided by your constant term in your divisor, which is minus 1. 15 divided by minus 1 gives me minus 15. I then have to work out what the middle term is going to be. I know that in a quadratic expression, the next term is going to be plus some coefficient of x, okay, where k could in fact be 0. All right, and I set up a little equation for myself to work out the value of k. I look at if I had to expand these brackets, which terms will add up to give me the x squared term in my polynomial f of x? Well, I would simply multiply the minus 1 by the x squared, which gives me minus x squared, and then I would need to multiply x by kx, so it would be plus kx squared, and if I add that together, it needs to give me my x squared term. It needs to give me the value of that, which is 1x squared. And I simply solve for k. So I'm going to say kx squared is equal to 1x squared. Take your minus x squared over to the right hand side, so it becomes plus x squared. So kx squared is equal to 2x squared. Therefore, k must be equal to 2. So therefore, my quadratic bracket here is x squared plus 2x minus 15. And then you need to factorize that all completely, right? So therefore, your function f of x is going to be equal to x minus 1 times, factorize your quadratic expression as well. So it's x plus 5 times x minus 3. And all I've done there is I've factorized this expression, x squared plus 2x minus 15, to give me the other two factors. And all of these, each of these are your roots of your cubic polynomial. All right, guys, you learned so many different concepts today. I hope that you understand all of them. And if you didn't, make sure that you take down lots, that you've taken down lots and lots of notes. Go over those notes that you've taken down. Until next time, cheers.